Hi, my name is Alex Baldauf, and this is my EE3 final project. And for my final project, I did a garage door. And so the project goals was to create a garage door that would open up 90 degrees when it senses an object approaching it. And the way it would sense the object approaching it would be I would have a infrared LED constantly shining into infrared light sensor. And when the light sensor no longer detected any light, it would mean that an object had disrupted that light, and which would cause the door to open up because it means that the object is waiting to go through. And so after a certain amount of time, after opening up, the door would stop, allowing the man or object or car to go through the door. And then it would close after them after a set amount of time had passed. And this was implemented using an Arduino Uno. And so some important concepts to understand for this is the DC motor. And what the DC motor does is that it spins in a certain direction if a voltage drop is applied across its terminals. And it would spin directions if you reverse the direction of the voltage drop across its terminals, which is what I use to open the door and then close the door. I would spin it one way to open it and then let it down by spinning in the other direction. And so another one is the infrared LED and the infrared light sensors. And so basically the reason I used infrared light is that ambient light wouldn't disrupt it, so you can't just walk into a particularly bright room and have the door automatically open by accident, even if there's no object waiting to go through. And these LEDs are very directional, they're very highly directional, so unless you're pointing it directly at the receiver, you're not going to get many usable values or any readings from it, which allows you to create kind of like a tripwire of sorts to sense when an object breaks that tripwire and for you to open the door. And so another important concept to understand is the H-bridge. And basically what the H-bridge does is it allows you to control the voltage drop across the motor. And here's a couple pictures of both of the H-bridge and its a few different states. And so you have these four switches, power, ground, and the motor inside of this whole thing. And so if this switch and this switch are closed and this switch and this switch are open, what it does is it allows the current to pass through in this highlighted path, which allows the voltage drop to go from right to left, which would cause the motor to spin in a certain direction. And then if you were to close the open switches and open the closed switches, then the current would flow in the opposite direction, which would cause the motor to spin in the opposite direction. And so here's a graph of the data from my infrared light receiver. And so here is the values that I read from the receiver, listing from a 0 to 1024. And here's the distance between the two, the LED and the sensor, in inches. And just for reference, the higher this number is, the less light it's detecting. And so the resting value of the receiver was around 990, so I didn't want to accidentally set off the door without getting close to approaching that, so I set the trigger value to around 800. And according to my graph, for a trigger value of 800, you need a distance of less than 7 inches. But this 7 inches is or the way this data was taken was that this value that's corresponding to this distance is the minimum value you can get from that distance. So unless your LED is pointing at the receiver perfectly, you won't get this value. You'll get a higher value, which won't work. So you'll probably want to set it to 5 or 6 inches for it to work properly. And I also need to find out how long I need to run the motor to get the door open, because if I ran the motor too long, then the string used to raise the door up would snap, and if I didn't run the motor long enough, the object wouldn't be able to pass through because the door isn't raised high enough. And so here's the door angle in degrees from the vertical, and here's the motor runtime in milliseconds. And so my ideal opening angle is 90 degrees because that seems like a good clean number to aim for. And so according to my graph, to get an angle of 90 degrees, I needed to run my motor for around 960 milliseconds, and that gets me the angle I want. And so the door wasn't perfect. Basically, if you kept running it, running the motor over and over, eventually the door wouldn't open quite as high. So it would start out at 90 degrees and then it would go to like 80 degrees and 75 degrees. And there were two reasons for this. One was that the tape that was used to hold the door open would shift slightly, maybe by a millimeter or two, every few times the motor was run, and that doesn't seem like much initially, but after like a dozen or 2 dozen numbers of runs, that that gets to be a sizable amount, and there's too much slack in the string, and which causes the motor to not open the door as much. And the other reason was that depending on the direction you're spinning the motor runs at different speeds, and so for my motor ran slower when I was opening the door and faster when I was closing the door. So I needed to have it open the door for longer than it was closing, and because of that discrepancy, it's not as simple as setting the opening time and the closing time to be the same. You have to kind of like fiddle around with the numbers to get them to be about as effective at opening as closing it. And so as you can see here, this is kind of an asymptotic graph. And most of this is due to the tape shifting because I tried to get my the differences in my just opening the door and closing the door with the times to be as small as possible. So most of this is from the tape shifting, and you can see that the effect gets lower the more it's displaced from the 90-degree point, and that's because of the orientation of the door with the motor. It's kind of hard to show without an image, but after it gets around 80 degrees or so from the vertical, the effect from the tape moving will be diminished, so it would kind of taper off around 15 degrees here, so it would end up at 75 degrees after a long while. And so in conclusion, the door was able to sense an object in front of it. The door opened, stopped, let the object through, and then closed properly. And there wasn't too much overshoot, except for that little bit due to the string, which is kind of hard to avoid. But overall, because you could run it probably like 20 to 25 times without too many issues in terms of overshoot, the project goals are met and the door was successful. And this is my reference for the H-bridge picture that I showed. It was taken online from this website here, blogs.solutioncubes.com.